If you use a resistor incorrectly in a circuit, it will get burned out, and this will cause damage to the whole circuit or cause a big fire. So it is very important to understand how resistors work and all their working principles in a circuit. Welcome to this step-by-step resistor tutorial. In this video, I am going to walk you through almost everything you need to know about resistors. I will explain and show you practically the working of 1. What is a resistor? 2. What are the types of resistors? 3. How to read resistor color code. 4. How to read a resistor with a multimeter. 5. A resistor in parallel. 6. A resistor in series. 7. A resistor as a voltage divider. And 8th, a resistor used in biasing a transistor. So watch this video to the end so you will have a better understanding of how resistors work. So let's get started. You are welcome back. So now what is a resistor? But before I talk about what a resistor is about, I will firstly want you to know that a resistor is one of the most common types of electronic components. They are used in various circuits. So now let's define what a resistor is. A resistor is defined as a passive electrical component with two terminals that are used for either limiting or regulating the flow of electric current in electrical circuits. So now that you know what a resistor is, let me now list the types and categories of resistors, although there are numerous types of resistors that are available and can be used in electronic circuits. But these different types of resistors have different properties depending upon their manufacture and construction. But with all those types available out there, there are two main classifications of resistors, which are linear and nonlinear resistors. But to make it easier, let's talk about each of them step by step. So let's talk about what linear resistors are. They are components that maintain a constant resistance value regardless of the voltage or current passing through them, which means that they follow Ohm's law. But there are two basic types of linear resistor properties. The first one is fixed resistors, and the other type is variable resistors. In a short form, fixed resistors are resistors with a specific value. Fixed resistors are one of the most widely used types of resistors. They are used in electronic circuits to set the correct conditions in a circuit. There are also various types of fixed resistors. We have 3 commonly used ones in the circuit: 1 wire wound resistors, 2 thin film resistors, and 3 carbon composition resistors. So that is it for fixed resistors, and I hope you understand what they are now. So real quick, let's talk about the other types of linear resistors, which are variable resistors. This type of resistor is an electronic component that allows for the adjustment of resistance in a circuit. They are used to control the flow of current in a circuit by changing the amount of resistance offered to the current. This variable resistor also has different types that can be used in a circuit. Its types are 1. Potentiometer, 2. Rheostat, and 3. Trimmer resistor. So now at this point you understand what a linear resistor is and their types and what they are used for. The next thing we will talk about is the nonlinear resistor. Those are the types of resistors that do not have a constant relationship between the voltage and current. They change due to temperature and they do not follow Ohm's law. There are also several types of nonlinear resistors, but let's take a quick look at only 2 of the nonlinear types of resistors. 1. Thermistors are a type of resistor that notices the change in temperature. In other words, it is a 2-terminal device that is very sensitive to temperature. So we can say that the resistance of a thermistor is inversely proportional to the temperature. The other type is a photoresistor, or LDR, known as a light-dependent resistor. LDR is a light-controlled variable resistor. The photoresistor's resistance decreases with an increase in incident light intensity. So we can say that the resistance of an LDR is inversely proportional to the light. Guys, before we go to the next chapter, I have very exciting news for you. For a while now, I have been getting a lot of questions, such as how to know about solar and inverter installations. How do I know the right components for solar? Where can I learn solar and inverter installations from? And how to start a solar inverter as a beginner, and many more. Well, if you are curious about anything like that, everything is now being revealed. And I'm glad to announce my full solar and inverter installations course, made in ebook format, is now available. You're going to be able to access everything I know about solar and inverter installations. Literally everything I've spent years learning is now being put down in an easy-to-follow system. I lay out everything for you step by step. You can install solar inverters yourself, and you can learn yourself anywhere in the world with complete freedom. So if you want to learn this and start your journey today, Just click on the link in my description below or in my bio. I am certain you are going to love it, so just scroll to the description or bio now and click the course link, and I will see you there. So now let's talk about the color code of resistors, how to read them, and know the actual value of a particular resistor. So what is the resistor color code? Resistors are usually very tiny, and it is challenging to print resistance values on them. So color bands are printed on them to represent the electrical resistance. These color bands are known as resistor color codes. The resistor color code was invented in the 1920s by the Radio Manufacturers Association, REMA. The number of bands present in a resistor varies from 3 to 6. The first two bands indicate the resistance value, and the third band serves as a multiplier. In this section, let us discuss how to read resistor color codes, look at an example, and learn a mnemonic to remember the number sequence. But before we look into this example, it will be very important for you to know how to use the resistor color table, which the color starts from black, which represents 0 on the digit and 1 on the multiplier. You can take a screenshot and save it to use to find color values later. So now that you have the table, let's take a quick look at how to read the resistor color code. To read them, hold the resistor such that the tolerance band is on your right. The tolerance band is usually gold or silver in color and is placed a little further away from the other bands. Starting from your left, note down all the colors of the bands and write them down in sequence. Now, use the table given to see which digits they represent. The band just next to the tolerance band is the multiplier band. So if the color of this band is red, representing 2, the value given is 10 raised to the power of 2, or let's call it 0, 0. So now let's use this resistor as an example. As we know, the first two colors represent the significant digits of the resistance value, so the given colors represent digit 1, which is brown, and digit 0, which is black. The third band is a multiplier band, so the color red represents a multiplier factor, and red is 2, which is 0, 0 in multiplier. The last band represents the tolerance level, and the tolerance level of the resistor is plus or minus 5% tolerance. So in this case, the resistance value of this resistor is 1000 ohms with plus or minus 5% ohms, or 1 kilo ohm. As you can see on the multimeter, it is showing 0.97 kilo ohms. It means that 0.03 kilo ohms is the 5% tolerance, which is minus. This is just for example 1, and for you to better understand it yourself, I will show you one more example. So let's use this resistor for the second example. The given colors represent digit 2, which is red, and the second is also 2, which is also red. The third band is a multiplier band. However, the color brown represents a multiplier factor, and brown is 1, which is 0 in multiplier. The last band represents the tolerance level, and the tolerance level of the resistor is plus or minus 5% tolerance. So in this case, the resistance value of this resistor is 220 ohms, with plus or minus 5% ohms, or 0.22 kilo ohms. As you can see on the multimeter, it is showing 218 ohms, which means that 2 ohms is the 5%. So now I hope you understand how to read the color bands on a resistor and how to interpret the values correctly. And it is also very important to understand this table and memorize all of these colors, digits, multipliers, and tolerances. So now let's go to the next section. So now in this section, what we are going to talk about is resistors in series and parallel, how they work, and practically how they are being used in a circuit. But before we go into that, I think you really need to understand that resistors are being used in series and parallel configurations for various reasons in a circuit, and literally one of the important things about using resistors in parallel and series is to control the voltage and current flowing through different components. Yeah, so in this case, by arranging resistors in these configurations, we can achieve desired resistance values, manage power distribution, and ensure that the circuit operates efficiently without overloading any individual component. So now that you understand that, let's take a look at what it means for a resistor in series first. If 2 or more resistors are said to be connected in series, the resistance of each resistor will be added together to make a total resistance value and make the same amount of current flow through all the resistors. In that type of circuit, the voltage across each resistor is different. In a series connection, if any resistor is broken or a fault occurs, then the entire circuit is turned off. The construction of a series circuit is simpler compared to a parallel circuit. So practically look at these resistors. The two resistors are connected in series. Since the first resistor is 15 ohms and the second resistor is also 15 ohms, the total resistance equals 15 plus 15, or 30 ohms. As you can see in the multimeter display, it shows that the total ohms of these resistors in this series connection is 30.2 ohms. This indicates a tolerance of plus 5%, as the resistance is slightly higher than the actual resistor value. Now that you have a clear understanding of how resistors function in series, let's discuss their operation in parallel. If two or more resistors are connected in parallel, the resistance value of the resistors will be divided, and the voltage is the same across all the resistors. So in a circuit like this, a resistor or any other component can be connected or disconnected easily without affecting other elements in a parallel circuit. So now in this circuit, we have two resistors connected in parallel. Each of them is 15 ohms. To calculate the result, we will add the total value of the resistors, which is 15 plus 15, that is 30, and we will also multiply the total value of the resistors, which is then 15 multiplied by 15, that is 325, 225. Then we will then divide the multiplied result with the additional result. So that is 225 divided by 30. The answer is 7.5 ohms. But remember, we have plus or minus 5% tolerance. So as you can see on the multimeter display, it shows that the total ohms is 8.1 ohms, which means the tolerance is plus 5%. So now I hope you understand how resistors work in series and parallel. Now, if you do not understand, you can leave a question in the comment section. So now let's go on to the next topic. So now the next thing we are going to talk about is how to use resistors as a voltage divider. In a short form, let me explain that using resistors as voltage dividers means connecting two or more resistors in series to create a circuit where the input voltage is divided proportionally across each resistor, resulting in a smaller output voltage at a specific point in the circuit, with the exact voltage depending on the ratio of the resistor values. It's a simple way to reduce a voltage to a desired level using only resistors. It is very important for you to know how to calculate when you are using a resistor as a voltage divider. To calculate the voltage across a resistor in a voltage divider circuit, use the formula volt out equals volt in multiplied by R2 divided by R1 plus R2, where volt out is the output voltage across resistor R2. Volt in is the input voltage. R1 and R2 are the two resistors in series. And the key point is that R2 is the resistor you want to measure the voltage across. So let's use some practical examples to see how voltage dividers work. These resistors are 15 ohms each. Then they are connected in series, and 7.37 volts DC was connected. The negative probe was connected to one end, and the positive probe was connected to the other end. To know the volt out, multiply 7.37 by the result of R2 divided by R1 plus R2, which is 15 divided by 15 plus 15. So now let's say 15 divided by 30, which is 0.5. Then we say 7.37 multiplied by 0.5. The result is equal to 3.68 VDC. So as you can see on the multimeter, we have 3.68 DC volts. Oh yeah, now I hope you understand how to calculate it for yourself. If you also have any questions, please do well to drop them down below in the comment section. So let's now go to the final part. So this is the last part where I am going to explain to you step by step and practically how resistors are used in biasing transistors. But before that, I believe it is also very important for me to explain to you what it means when resistors are used in biasing transistors. Basically, in biasing a transistor, resistors are used to control the voltage at the base of the transistor, thereby setting its operating point and determining how much current flows through the transistor. They act as a voltage divider to provide a stable and precise bias voltage to the base, minimizing the impact of variations in the transistor's beta value and temperature changes. So in this circuit, I am using an LDR to bias the transistor together with other resistors to make the circuit work just like a voltage divider. In the circuit, we have R1, R2, and R3. R1 is the LDR, R2 is to make a voltage divider, and R3 is for limiting the flow of current from the positive input to the LID. So now I hope you understand everything we have done so far. If you watched to this stage, please comment, I want more of this. So thank you for watching to the end, I really appreciate it. Please click on the like button, subscribe, and comment on what you want me to make a video on next. Have a nice day, peace, and love.